Hello, my name is Ola Dahl. I work at Ericsson in Stockholm, Sweden. I will talk to you about software analysis using virtual platforms. At Ericsson we do communication systems, and right now we are in the rollout and manufacturing and design of the 5G products. So it's an exciting time at Ericsson right now. I work with digital ASICs and FPGAs that we put in the baseband processing units and in the radio units in the base stations. And for these ASICs and FPGAs, we make simulators that we call virtual platforms. Those simulators are used by software design to run software and test software, and also to develop software before the ASIC and the FPGA is manufactured. So these virtual platforms that you can see here, we call it SVP. They simulate ASICs and FPGAs and also complete boards. We have different development teams. We are about 50 persons doing these virtual platforms, and we also do individual models that we use in RTL verification. We have been doing these virtual platforms since 2011, and we have been working together with Cadence engineers for this period of time. When these platforms run software, all software is not always perfect. There are bugs in the software, and we have been asking ourselves, and also software stakeholders have asked us, what if you could instrument the virtual platform so that when it runs the software, it could look at the software and find errors in the software? Then if we could do that, then you can find bugs in the software before it is released into production and before it reaches the live networks. So we took that question and we analyzed it, and we have developed this functionality so that we can analyze the software while it runs. And we have two flavors of this analysis. The first flavor we call memcheck. The memcheck flavor checks for uninitialized data. So if you in your software have uninitialized variables that you use in your program, this feature will detect that usage and give you an error report. And then you can fix those types of bugs before they go into production. And these bugs could be really hard to find, because if you have uninitialized data, it could be so that the data value that you have is a good one and then it works. It could also happen that in the next run it is a bad value and then it will not work. So it's important to detect that the value is really uninitialized. The second flavor we call concurrency analysis. That is that we detect bugs that relates to concurrency. And that is, for example, when two processors use data in common, and it's important that they keep this data consistent, that they don't destroy it. And in order to check for that, we have this feature that checks that the data is protected in a proper way by software. So in this way we can detect also these kinds of bugs, which, like the other ones, can be very tricky to find and perhaps may not show up in all tests. Here is an example where we visualize the detection of errors. We have two processors running software, and they run a program where they send message to each other, and this program in this case happens to work. It happens to work because uninitialized data have beneficial values. But when you run it with our tool, we will detect the uninitialized usage of data in these red points, and we will report these errors, and you have the chance to fix them before you release the software. So we have this feature in our virtual platform. We think it's a valuable concept, and we think that tool creators like Cadence and others could also use this idea so that it can be implemented in other tools. For example, if you make virtual platforms or processor models. And we use it in production software right now. We have found bugs, and we collaborate with software engineers at Ericsson, and we think it's a very interesting concept. Thank you for listening.